Welcome to a peaceful exploration of one of Earth's most serene, yet fascinating landscapes. As you settle in, allow your mind to drift with us to the heart of Turkey's central plateau, where the ancient valleys of Cappadocia have been quietly shaped by millions of years of gentle geological processes. The soft volcanic tuff that forms these landscapes has been gradually carved by nothing more urgent than time itself, creating a place where human history and natural processes have unfolded at their own unhurried pace. Tonight, we'll wander through these tranquil formations, exploring their quiet evolution and the gentle relationship between the land and those who have called it home across the centuries. As you breathe deeply and comfortably, imagine the warm, dry air of the Anatolian plateau. Not too hot, not too cold, but perfectly balanced for our journey through this landscape of soft contours and distant horizons. The valleys of Cappadocia extend before us like a peaceful ocean of earth tones, buff creams, gentle ochres, and soft beiges, colors that have remained largely unchanged for thousands of years. This is a place where time moves differently, where geological processes operate on scales so vast that they appear almost motionless to our perception, creating the perfect setting for our minds to slow and our thoughts to settle into a natural, restful rhythm. Cappadocia rests in the center of what is known as the Anatolian Peninsula, approximately 730 kilometers east of Istanbul and 285 kilometers south of the Black Sea. This central plateau region sits at an average elevation of 1,000 meters above sea level, creating a moderate highland climate that has shaped both the natural features and human activities throughout its long history. The region we'll explore tonight encompasses roughly 5,000 square kilometers of varied terrain, with the most distinctive valleys concentrated in an area of approximately 100 square kilometers. The soft, porous stone that defines this landscape began forming approximately 10 million years ago during a period of mild volcanic activity. 3 now dormant volcanoes, Mount Ursiais at 3,916 meters, Mount Hassan at 3,268 meters, and the lesser-known Mount Melindez at 2,963 meters, released layers of ash, lava, and mud across the plateau over thousands of years. This material, known as tuff, settled in layers of varying density, creating the foundation for what would eventually become our valleys. Unlike dramatic, sudden geological events, this process occurred gradually and steadily, with each volcanic event separated by decades or centuries of quiet rest. As we journey further into understanding this tranquil landscape, we might note how the region is bordered by several mountain ranges that cradle these valleys in their gentle embrace. To the north, the modest elevations of the Kızılırmak mountain range create a natural boundary, while to the east, the terrain gradually rises toward the more substantial mountains of eastern Anatolia. The southern edge of Cappadocia transitions slowly into the Taurus Mountains, which separate the central plateau from the Mediterranean coastal regions. These surrounding features create a naturally enclosed basin, protecting the valleys from harsh weather patterns and contributing to the relatively constant climate that has allowed for such distinctive weathering patterns over millennia. The primary waterway of significance in this region is the Kızılırmak River, which translates to Red River in Turkish, named for the reddish sediment it carries along its unhurried journey. At 1,355 kilometers, it is Turkey's longest river, though where it passes through Cappadocia, it moves at a particularly gentle pace, having carved a wide, shallow valley over thousands of years. Several smaller tributaries branch from this main waterway, creating patterns of moisture that have influenced the erosion processes throughout the valleys. These include the Damsa stream, which flows at an average rate of 0.8 cubic meters per second, and the Uzungi stream, moving slightly slower at approximately 0.5 cubic meters per second during typical conditions. The human history of Cappadocia extends back approximately 7,500 years, with evidence of Neolithic settlements dating to around 5,500 BCE. Unlike regions with tumultuous historical narratives, Cappadocia's story is one of gradual adaptation and peaceful coexistence with the landscape. Early inhabitants discovered that the soft volcanic tuff could be easily carved, leading to the development of cave dwellings that remained at consistently pleasant temperatures throughout the year, approximately 18 to 20 degrees Celsius regardless of external conditions. This tradition of living within the landscape, rather than attempting to dramatically alter it, continues to the present day, representing one of the world's longest continuous adaptations to a specific geographical feature. As we continue our gentle exploration, we might consider how the boundaries of what we call Cappadocia have shifted slightly over time, never through conflict, but through the natural evolution of cultural understanding. In ancient Persian texts from around 600 BCE, the region was referred to as Cappadocia, meaning the land of beautiful horses, encompassing a somewhat larger area than what we consider Cappadocia today. During the Roman period, from approximately 17 CE, administrative boundaries adjusted slightly, reducing the region to roughly 7,500 square kilometers. The Byzantine era saw further refinement of these boundaries, eventually settling into the general understanding we have today of this peaceful landscape. The distinguishing topographical features of Cappadocia are its valleys, plateaus, and the distinctive formations known commonly as fairy chimneys. These features have developed through a process known as differential erosion, where softer layers of volcanic tuff wear away more quickly than harder layers, creating these characteristic columns topped with more resistant caps of basalt or similar materials. This process occurs at an exceptionally slow rate, with typical erosion removing between 0.5 and 2 millimeters of material per year, depending on local conditions and the specific mineral composition of the tuff in each area. Among the most serene of these valleys is the Rose Valley, named for the gentle pink hue of its stone during certain lighting conditions, particularly in the early morning and late afternoon. This valley extends for approximately 3.7 kilometers in a roughly northwest to southeast orientation, with walls that rise gradually to heights ranging from 50 to 85 meters. The valley floor varies in width from 20 meters at its narrowest points to approximately 70 meters at its widest sections. Throughout this peaceful corridor, the differential erosion has created rounded formations that resemble gentle waves frozen in stone, with each wave separated from the next by distances ranging from 5 to 15 meters, creating a rhythmic pattern as one moves through the space. Adjacent to the Rose Valley lies the slightly larger Red Valley, which connects with its neighbor at several points through openings ranging from 5 to 12 meters wide. The Red Valley extends for nearly 4.8 kilometers and displays a more pronounced color variation due to higher iron oxide content in certain layers of the tuff. Iron oxide levels in these sections typically range from 4.2 to 6.7%, compared to the average 2.1 to 3.5% found in surrounding areas. This higher concentration creates the warm, reddish tones that give the valley its name, with color intensity measurements ranging from 28 to 47 on the standard geological color intensity scale, compared to typical readings of 15 to 25 in neighboring formations. The Pigeon Valley, extending for approximately 4 kilometers between the small settlements of Gurim and Ushisar, features walls dotted with thousands of small openings. These openings, measuring typically between 15 and 30 centimeters in diameter, and extending inward to depths of 40 to 75 centimeters, were carved by locals over many generations to create roosting places for pigeons. The valley itself has an average width of approximately 35 meters at its floor, with walls rising to heights between 60 and 90 meters. The slope angle of these walls ranges from 65 to 78 degrees in the steeper sections to 30 to 45 degrees in areas where more extensive erosion has occurred. The Love Valley, named for its distinctive columns that rise with gentle tapering from bases of approximately 3 to 5 meters in diameter to narrower sections of 1 to 2 meters before expanding slightly at the top, contains approximately 150 major formations spread across an area of roughly 1.8 square kilometers. These columns range in height from 10 meters for the smaller examples to impressive formations reaching up to 40 meters. Spacing between individual columns varies from as little as 2 meters to wider gaps of approximately 15 meters, creating peaceful corridors through which one can wander. The geological composition of these particular formations includes volcanic tuff with a slightly higher concentration of rhyolite, typically 8.3 to 10.2%, compared to the regional average of 6.7%, which contributes to their greater resistance to erosion and their distinctive shapes. The Devrant Valley, sometimes called Imagination Valley, covers a smaller area of approximately 0.75 square kilometers, but contains some of the most varied formations. Within this limited space, erosion has created approximately 200 distinctive shapes, with heights ranging from small formations of just 2 to 3 meters to larger columns reaching 25 meters. The density of formations here is higher than in other valleys, with an average of one significant formation per 37 square meters, compared to the regional average of 1 per 120 square meters. The geological composition in Devrant Valley shows a slightly higher concentration of andesitic materials, typically 12.3 to 14.7%, compared to the regional average of 9.2%, which has influenced the more complex erosion patterns found here. The Zelv Valley presents a slightly different topographical profile, with 3 converging valleys creating a roughly Y-shaped formation extending over an area of approximately 2.3 square kilometers. The 3 branches of this valley system measure 1.4 kilometers, 1.1 kilometers, and 0.9 kilometers, respectively. The valley walls in Zelv rise to heights between 45 and 110 meters, with slope angles ranging from 40 to 85 degrees. The width of the valley floor varies considerably, from narrow passages of just 8 meters to wider sections measuring up to 50 meters across. The tuff in Zelv contains a marginally higher percentage of pumice fragments, typically 7.8 to 11.3%, compared to the regional average of 5.4%, giving it a slightly more porous texture and influencing its distinctive erosion patterns. Monk's Valley, named for the cone-shaped formations that reminded early visitors of monks in robes, covers approximately 1.5 square kilometers and contains roughly 120 major formations. These formations range in height from 8 to 35 meters, with base diameters typically measuring between 3 and 7 meters. The spacing between formations is relatively consistent at 7 to 12 meters, creating a more regular pattern than found in many other valleys. The cap rocks that top many of these formations have an average diameter of 1.5 to 2.7 meters and thickness ranging from 0.7 to 1.4 meters, composed primarily of basalt, with hardness measurements ranging from 5.5 to 6.8 on the Mohs scale, significantly higher than the underlying tuff, which typically measures between 3 and 4 on the same scale. Between these distinctive valleys lie several plateaus with more subtle topographical features. The Uagup Plateau covers approximately 12 square kilometers at an average elevation of 1,150 meters above sea level. Its surface has a gentle undulation, with elevation changes rarely exceeding 20 meters over distances of 1 kilometer. The soil depth on this plateau ranges from 15 to 40 centimeters, overlying the volcanic tuff base. The Avanos Plateau, slightly larger at approximately 15 square kilometers, sits at a marginally lower average elevation of 1,050 meters. Its surface features even more subtle contours, with elevation changes typically limited to 5 to 15 meters over similar distances. Soil depths here range from 20 to 55 centimeters, with slightly higher clay content of 12 to 18% compared to the Ugu Plateau's 8 to 14%. The climate of Cappadocia is classified as a continental semi-arid steppe climate, designated as BSK under the Köppen climate classification system. This climate type is characterized by hot, dry summers and cold, somewhat snowy winters, with significant temperature variations between seasons. The average annual precipitation for the region is approximately 417.8 millimeters, with the distribution across months showing a gradual pattern of variation. January receives an average of 42.3 millimeters, February 35.7 millimeters, March 39.8 millimeters, April 44.6 millimeters, May 51.2 millimeters, June 36.9 millimeters, July 11.2 millimeters, August 7.8 millimeters, September 14.5 millimeters, October 30.2 millimeters, November 41.7 millimeters, and December 41.9 millimeters. The relationship between this precipitation pattern and the erosion rates of the tuff formations shows a correlation coefficient of approximately 0.72, indicating a strong but not absolute relationship. Areas receiving higher annual precipitation, particularly those exposed to the northeast winter winds, show erosion rates averaging 1.7 millimeters per year, while more sheltered areas with lower precipitation exposure erode at a slower average rate of 0.8 millimeters per year. This differential erosion contributes to the varied appearance of formations, even within relatively short distances of 200 to 300 meters. Temperature patterns in the region follow predictable seasonal variations, with average daily highs in January of 4.8 degrees Celsius, February 6.5 degrees, March 11.7 degrees, April 16.9 degrees, May 21.8 degrees, June 26.3 degrees, July 30.1 degrees, August 30.4 degrees, September 25.7 degrees, October 19.8 degrees, November 13.2 degrees, and December 7.1 degrees. Average daily low temperatures follow a similar pattern. January minus 4.3 degrees, February minus 3.5 degrees, March 0.2 degrees, April 4.8 degrees, May 8.7 degrees, June 12.5 degrees, July 15.6 degrees, August 15.3 degrees, September 11.1 degrees, October 6.4 degrees, November 1.3 degrees, and December -2.6 degrees. The diurnal temperature variation, the difference between daily high and low temperatures, averages 11.2 degrees Celsius across the year, with the smallest variations occurring in winter months, average 9.1 degrees, and the largest in summer months, average 13.6 degrees. This consistent temperature range creates cycles of expansion and contraction within the rock that contribute to the weathering process, with an estimated contribution to overall erosion of approximately 22 to 29%, according to geological studies conducted between 2008 and 2015. Wind patterns across the region show a predominant direction from the northeast during winter months, November through March, with average wind speeds of 18.3 kilometers per hour. Summer months, June through August, see a shift to predominantly northwestern winds with lower average speeds of 12.7 kilometers per hour. Spring and autumn months experience more variable wind patterns with directional consistency measurements of 0.43 and 0.51 respectively, compared to winter's 0.76 and summer's 0.68, where a measurement of 1 would indicate completely consistent direction. The vegetation of Cappadocia is adapted to the semi-arid conditions, with plant density measurements averaging 28 individual plants per square meter in more hospitable areas, and declining to as few as 7 plants per square meter in the most exposed locations. Species diversity follows a similar pattern, with an average of 5.7 species per 100 square meters in sheltered valleys, rising to 12.3 species per 100 square meters where more moisture is available. The relationship between vegetative cover and erosion rates shows an inverse correlation of -0.81, with areas of denser vegetation experiencing measurably slower erosion rates. The population density across the Cappadocia region averages approximately 25 people per square kilometer, significantly lower than Turkey's national average of 109 people per square kilometer. This population is distributed unevenly, with concentrations in several small towns and villages. Ugup has a population of approximately 21,500, Avanos 13,800, Gurim 2,200, and Ushisar 1,700. The relationship between settlement size and proximity to valleys shows a correlation coefficient of 0.68, indicating that human settlement patterns have been meaningfully influenced by the topographical features. Land use patterns across the region show agriculture occupying approximately 47.3% of the usable land area, with vineyards comprising 12.7%, orchards 8.5%, and field crops 26.1%. Natural vegetation covers approximately 38.6%, while built environments account for 8.2%. and transportation infrastructure occupies 5.9%. The average field size for agricultural plots is 0.85 hectares, with a standard deviation of 0.37 hectares, reflecting the traditional small-holding farming practices that have characterized the region for centuries. The geological composition of the tuff that forms these valleys shows slight variations across the region, influencing the specific erosion patterns. Silica content ranges from 58.7 to 64.3%, aluminum oxide from 16.2 to 18.9%, iron oxide from 2.1 to 6.7%, calcium oxide from 3.2 to 5.8%, magnesium oxide from 1.3 to 2.9%, potassium oxide from 2.8 to 4.7%, and sodium oxide from 3.1 to 4.2%. These variations, while seemingly minor, create differences in hardness ranging from 3.1 to 4.2 on the Mohs scale, sufficient to influence erosion rates by factors of 1.3 to 1.7 between the softest and hardest examples. The hydrological network within the region includes approximately 840 kilometers of seasonal streams and 215 kilometers of perennial waterways. Groundwater levels vary seasonally by an average of 3.2 meters, with the highest levels typically occurring in late May and the lowest in late October. The porosity of the tuff allows for relatively efficient water movement, with percolation rates averaging 18 millimeters per hour in typical samples, rising to 27 millimeters per hour in more porous examples, and falling to 12 millimeters per hour in denser formations. The climate of Cappadocia follows annual cycles that repeat with subtle variations from year to year. January temperatures remain consistently cold, with an average daily mean of 0.25 degrees Celsius. Day-to-day temperature variations in January show a standard deviation of approximately 3.7 degrees, creating a predictable rhythm of slightly warmer and slightly colder days within the overall winter pattern. February continues this pattern with a marginally higher average daily mean of 1.5 degrees Celsius and a similar standard deviation of 3.9 degrees. March sees the beginning of a gradual warming trend, with the average daily mean rising to 5.95 degrees Celsius and day-to-day variations increasing slightly to a standard deviation of 4.2 degrees as the transition toward spring progresses at its unhurried pace. April brings more noticeable warming, with the average daily mean reaching 10.85 degrees Celsius. Day length increases steadily throughout this month, from 12 hours and 41 minutes at the beginning to 13 hours and 51 minutes by the end, adding approximately 2.3 minutes of daylight each day. This gradual increase in solar radiation contributes to surface soil temperature increases, averaging 1.8 degrees Celsius per week throughout the month. May continues this warming trend, with the average daily mean reaching 15.25 degrees Celsius. Soil temperatures at a depth of 10 centimeters average 14.7 degrees during this month, warm enough to support the germination of many native plant species, which typically require soil temperatures between 10 and 15 degrees for active growth. June marks the transition to summer conditions, with the average daily mean temperature reaching 19.4 degrees Celsius. Relative humidity levels begin their annual decline during this month, starting from an average of 52% in the first week, and typically falling to approximately 43% by month's end. This decline continues into July, which is typically the warmest month, with an average daily mean of 22.85 degrees Celsius. Relative humidity reaches its annual low during this month, averaging just 38%. Surface soil moisture levels also reach their minimum, with average volumetric water content falling to approximately 11% in the upper 5 centimeters of soil, compared to the winter average of 26%. August maintains similar temperature patterns to July, with an average daily mean of 22.85 degrees Celsius. The consistency of temperatures during this month is notable, with a standard deviation of just 2.1 degrees for daily means, the lowest of any month. This creates a period of exceptional stability in temperature conditions. September begins the gradual cooling trend, with the average daily mean falling to 18.4 degrees Celsius. Day length decreases steadily throughout this month, from 13 hours and 1 minute at the beginning to 11 hours and 47 minutes by the end, losing approximately 2.5 minutes of daylight each day. October continues the cooling pattern, with the average daily mean falling to 13.1 degrees Celsius. The first frost typically occurs during the last week of October, though this can vary by up to 10 days earlier or later, depending on specific conditions in any given year. November sees a more pronounced cooling, with the average daily mean falling to 7.25 degrees Celsius. The probability of frost increases significantly, with an average of 12 frost days during this month. December completes the annual cycle, returning to winter conditions with an average daily mean of 2.25 degrees Celsius. Snow becomes more common, with an average of 7.8 days receiving measurable snowfall during this month. The seasonal cycle of precipitation follows a different pattern than temperature, with the wettest period occurring during the spring months. The average number of days with measurable precipitation, defined as 0.1 millimeters or greater, follows this monthly pattern. January 11.2 days, February 10.5 days, March 11.7 days, April 12.3 days, May 12.8 days, June 8.4 days, July 3.1 days, August 2.6 days, September 4.3 days, October 8.7 days, November 9.9 days, and December 11.3 days. The intensity of precipitation also varies seasonally, with average precipitation per wet day showing this pattern. January 3.78 millimeters, February 3.4 millimeters, March 3.4 millimeters, April 3.63 millimeters, May 4 millimeters, June 4.39 millimeters, July 3.61 millimeters, August 3 millimeters, September 3.37 millimeters, October 3.47 millimeters, November 4.21 millimeters, and December 3.71 millimeters. The combined effect of these temperature and precipitation patterns creates distinct growing seasons and influences the weathering processes throughout the year. The primary growing season extends from mid-April through early October, a period of approximately 175 days. During this time, the accumulated growing degree days, using a base temperature of 5 degrees Celsius, average approximately 3,240 units. The relationship between growing degree days and vegetation density shows a correlation coefficient of 0.79, indicating a strong relationship between thermal conditions and plant growth. Wind patterns also follow seasonal variations that influence the experience of temperature and contribute to erosion processes. January winds average 19.7 kilometers per hour from a predominantly northeasterly direction, average 47 degrees. February shows similar patterns with average speeds of 19.2 kilometers per hour from a slightly more easterly direction, average 52 degrees. March winds begin a transitional pattern with average speeds of 18.5 kilometers per hour and more variable directions, standard deviation increasing to 32 degrees compared to winter's 24 degrees. April continues this transition with average speeds falling to 16.7 kilometers per hour and directional variability increasing further standard deviation of 38 degrees. May winds decrease in average intensity to 14.2 kilometers per hour, with directions continuing to show significant variability. June marks the beginning of the summer wind pattern, with average speeds of 12.8 kilometers per hour, predominantly from the northwest, average 315 degrees. July and August maintain similar patterns, with average speeds of 12.5 and 12.2 kilometers per hour, respectively, and consistent northwesterly directions, standard deviation decreasing to 21 degrees. September begins another transitional period, with average speeds increasing slightly to 13.7 kilometers per hour and directional variability increasing once again. October winds average 15.3 kilometers per hour with highly variable directions, standard deviation of 43 degrees, the highest of any month. November marks the return to the winter pattern, with average speeds increasing to 17.8 kilometers per hour and directions shifting back toward the northeast. December completes this cycle with average speeds of 19.3 kilometers per hour from a predominantly northeasterly direction. The effect of these seasonal variations on the erosion of the tuff formations is subtle but cumulative. Winter months contribute approximately 42% of the annual erosion due to the combined effects of freeze-thaw cycles, higher precipitation, and stronger winds. Spring months contribute approximately 31%, summer months just 12%, and autumn months the remaining 15%. This seasonal variability creates the distinctive weathering patterns that give each formation its unique character, with more protected faces eroding at rates up to 35% slower than those with direct exposure to prevailing wind and precipitation patterns. Cloud cover follows its own seasonal pattern, with average monthly cloudiness measured as octas, on a scale from 0 for completely clear to 8 for completely overcast, showing this distribution. January 5.2, February 5, March 4.8, April 4.5, May 4.1, June 3.3, July 1.8, August 1.7, September 2.2, October 3.4, November 4.3, and December 5.1. This pattern influences both the direct solar radiation reaching the landscape and the subjective experience of the region throughout the year. During summer months, the combination of low cloud cover, low humidity, and warm temperatures creates the distinctive clear atmospheric conditions that have made this region known for its remarkable visibility, typically allowing views extending 25 to 35 kilometers on average summer days. The human geography of Cappadocia has evolved gradually over thousands of years, with settlements adapting to the unique landscape rather than attempting to significantly alter it. The current population density of approximately 25 people per square kilometer has remained relatively stable over the past century, with modest fluctuations rarely exceeding 15% in either direction. The settlement pattern is dispersed, with an average distance between neighboring communities of 4.7 kilometers. This spacing has been influenced by traditional walking distances, with most settlements historically positioned so that neighboring communities could be reached on foot in less than an hour under normal conditions. The average settlement size in the region is approximately 3,850 residents, though this figure is somewhat skewed by the presence of a few larger towns. The median settlement size is 1,250 residents, perhaps more representative of the typical community. The distribution of settlement sizes follows an approximately logarithmic pattern, with the number of settlements in each size category decreasing predictably as the size increases. Settlements with fewer than 500 residents number approximately 42. Those with 500 to 1,000 residents number 27. Those with 1,000 to 2,500 number 15. Those with 2,500 to 5,000 number 8. Those with 5,000 to 10,000 number 4. And those exceeding 10,000 residents, number just 2. The age structure of the population shows a median age of 36.7 years, slightly above the national average of 32.4 years. The population pyramid shows a gradual tapering, with the age cohorts as follows: 0-14 years 18.3%, 15-24 years 14.7%, 25-39 years 21.2%, 40-54 years 20.5%, 55-69 years 16.8%, and 70 plus years 8.5%. The dependency ratio, measuring the proportion of non-working age population to working age population, stands at 51.3%, with the youth dependency component at 29.7% and the elderly dependency component at 21.6%. The traditional dwelling types in the region fall into 3 main categories: rock-cut dwellings, semi-rock-cut dwellings, and freestanding stone houses. Rock-cut dwellings, carved directly into the tuff formations, comprise approximately 15.7% of the total housing stock. These dwellings maintain remarkably stable interior temperatures, with annual variations averaging just 5.3 degrees Celsius between summer and winter, and diurnal variations averaging just 1.8 degrees. Semi-rock cut dwellings, which combine carved elements with conventional building materials, represent 32.4% of dwellings. These show somewhat greater temperature variations, with annual differences averaging 8.7 degrees and diurnal variations averaging 3.2 degrees. Freestanding stone houses, typically constructed from blocks cut from the same tuff, comprise 51.9% of dwellings. These experience the greatest temperature variations, with annual differences averaging 12.4 degrees and diurnal variations averaging 4.7 degrees. The economic activities of the region have diversified over time, but maintain strong connections to traditional practices. Agriculture remains significant, engaging approximately 28.5% of the working population. The agricultural land use breaks down into several categories: vineyards 26.8%, orchards 18.1%, vegetable production 15.7%, grain crops 33.2%, and other crops 6.2%. The average agricultural holding measures 1.7 hectares, typically divided into 3 to 5 non-contiguous parcels. This fragmentation results from the traditional inheritance patterns that divide land equally among children, creating increasingly smaller parcels over generations. Tourism has grown to become a significant economic sector, directly employing approximately 22.3% of the working population, and indirectly supporting an additional 15.7%. The seasonal pattern of tourism shows peak visitation during the months of May through September, with approximately 72.5% of annual visitors arriving during this period. October through April sees lower, but still significant visitation, accounting for the remaining 27.5%. The average length of stay for visitors is 2.4 nights, with significant variations by nationality. Domestic Turkish visitors average 1.8 nights, European visitors 2.7 nights, East Asian visitors 2.2 nights, and visitors from North America 3.1 nights. Traditional crafts persist as both cultural practices and economic activities. Pottery production in Avanos engages approximately 3.7% of the regional workforce, using clay deposits found along the Kızılırmak River. These deposits contain a distinctive mineral composition: silica 52.7%, aluminum oxide 19.3%, iron oxide 8.1%, calcium oxide 2.6%, magnesium oxide 3.4%, potassium oxide 2.1%, and sodium oxide 1.8%. This composition creates the characteristic reddish-brown color of the finished pottery and provides appropriate plasticity with a measurement of 19.3 on the Standard Plasticity Index, within the optimal range of 15 to 25 for hand-thrown pottery. Carpet weaving continues as both a domestic and commercial activity, engaging approximately 4.2% of the population. The typical loom size used in the region measures 1.8 meters in width, and the average carpet produced measures 6.5 square meters. The knot density in regionally produced carpets averages 195,000 knots per square meter, requiring approximately 170 hours of labor per square meter. The natural dyes traditionally used derive from plants found within the region: madder root for reds, weld for yellows, indigo for blues, and various combinations for intermediate colors. The use of these natural dyes has declined to approximately 35% of production, with the remainder using commercial dyes, though recent years have seen a gradual resurgence in traditional methods. The transportation infrastructure of the region consists of approximately 780 kilometers of paved roads and 1,250 kilometers of unpaved roads and tracks. The road density averages 0.41 kilometers per square kilometer, below the national average of 0.53. The average distance from any settlement to the nearest paved road is 0.73 kilometers. Public transportation options are limited, with 85% of households owning at least one private vehicle. The average age of these vehicles is 12.3 years, significantly above the national average of 8.7 years, reflecting both the generally lower income levels of the region and the tendency to maintain vehicles for longer periods. The educational facilities in the region include 87 primary schools, 42 middle schools, and 18 high schools. The average primary school serves approximately 120 students, with a typical student-to-teacher ratio of 17:1. The average distance traveled by primary students is 1.2 kilometers, by middle school students 2.7 kilometers, and by high school students 4.5 kilometers. Access to higher education requires travel outside the region, with the nearest universities located in Kayseri, approximately 70 kilometers from the center of Cappadocia, and Nigd, approximately 60 kilometers. Healthcare facilities include 12 hospitals and 35 clinics distributed across the region. The average distance from any settlement to the nearest healthcare facility is 5.3 kilometers. The ratio of healthcare professionals to population stands at 1 physician per 870 residents, below the national average of 1 per 583, but following a slowly improving trend, with a 12% increase in healthcare coverage over the past decade. The average hospital contains 47 beds, with an annual occupancy rate of 62.3%. Seasonal variations in healthcare needs show a slight increase during winter months, with January admissions typically 18% above the annual average, primarily related to respiratory conditions. The water supply for communities in the region comes from a combination of sources. Groundwater provides approximately 73.5%, surface water 21.2%, and rainfall capture systems the remaining 5.3%. The average daily water consumption per capita stands at 112 liters, below the national average of 217 liters, reflecting both the semi-arid conditions and more conservative usage patterns. Water quality measurements show average dissolved mineral content of 423 parts per million, within acceptable limits, but relatively high due to the geological characteristics of the region. Calcium accounts for approximately 87 parts per million, magnesium 42 parts per million, sodium 35 parts per million, and various other minerals the remainder. Electrical service extends to 99.7% of dwellings in the region, with the average household consuming approximately 2,850 kilowatt hours annually, approximately 18% below the national average of 3,480 kilowatt hours. Seasonal variations in electrical consumption show winter usage approximately 37% higher than summer usage, primarily due to heating requirements. The traditional heating methods in the region have gradually transitioned from predominantly wood-burning systems, which now account for just 23.7% of heating, to natural gas systems at 41.5%, electrical systems at 27.3%, and other systems such as geothermal or solar at 7.5%. The administrative structure of the region divides it into 4 districts and 112 municipalities. The average municipal budget stands at approximately 3.2 million Turkish lira annually, with typical allocations following this pattern. Infrastructure maintenance, 27.5%. Education, 18.3%. Healthcare, 12.7%. Administrative costs, 11.2%. Social services, 9.8%. Cultural programs, 7.4%. And various other categories, 13.1%. Tax collection efficiency averages 87.3% of assessed amounts, slightly above the national average of 84.1%. The most significant revenue sources for municipalities include property taxes at 31.7%, income taxes at 28.3%, business licenses at 15.4%, and various other sources at 24.6%. Traditional land use patterns in the region have evolved gradually over centuries, with changes typically occurring at rates of less than 0.5% per year. The current distribution shows agricultural land at 47.3%, natural vegetation at 38.6%, built environment at 8.2%, transportation infrastructure at 5.9%, and water bodies and wetlands at the remaining 0.3%. The boundaries between these different uses often feature transitional zones averaging 18 meters in width, creating gradual rather than abrupt changes in landscape character. These transitional areas often contain the highest biodiversity in the region, with species counts typically 35 to 40% higher than in the more homogeneous zones they separate. Population movement patterns show a modest net outmigration from the region of approximately 0.3% annually over the past 2 decades. Age-specific migration patterns reveal that the 1824 age cohort shows the highest outmigration rate at 2.1% annually, primarily for educational and early career opportunities. The 60-plus age cohort shows a small net immigration of 0.4% annually, consisting primarily of return migration of individuals who left earlier in life. Internal migration within the region follows a gradual urbanization pattern, with the larger settlements gaining population at approximately 0.7% annually from smaller surrounding communities. The preserved historical structures in the region number approximately 1,700 cataloged sites, giving an average density of 0.34 historical sites per square kilometer. These include rock-cut churches, monasteries, underground cities, and traditional dwellings. The churches, numbering approximately 380, contain fresco paintings covering an estimated total area of 12,000 square meters. The pigments used in these frescoes derive primarily from mineral sources found within the region. Iron oxides for reds and yellows, copper compounds for blues and greens, calcium compounds for whites, and manganese compounds for browns and blacks. The durability of these pigments has varied, with average color retention estimated at 72% of original intensity after approximately 1 millennium. based on comparison with protected areas and documentary descriptions. The underground cities, of which 36 have been extensively documented, comprise an estimated total of 190 kilometers of tunnels and 8,500 chambers of various sizes and functions. These structures typically extend to depths of 40 to 85 meters below the surface, with the average depth being approximately 55 meters. Temperature within these structures remains nearly constant throughout the year at 16 to 18 degrees Celsius, regardless of external conditions. Humidity levels similarly remain stable at 65 to 75% relative humidity. These stable environmental conditions contributed to the preservation of many artifacts and structural elements, with estimated degradation rates approximately 35% lower than for comparable items in surface structures. The agricultural calendar of the region follows seasonal patterns that have remained largely consistent for centuries. Spring planting typically begins in late March for early crops and extends through mid-May for later plantings. The growing season averages 175 days, with the first harvest activities beginning in mid-July and extending through late October for the latest crops. Grape harvesting, a particularly significant activity, typically occurs from early September through mid-October, with specific timing adjusted based on sugar content measurements that optimally range from 18 to 22%, depending on the intended use. The agricultural cycle creates periods of varying labor intensity, with peak labor requirements in May planting and September harvesting, typically 2.7 times the annual average. The daily rhythm of life in traditional communities follows patterns synchronized with natural daylight. The typical workday begins approximately 1 hour after sunrise and concludes approximately 1 hour before sunset, creating seasonal variations in work hours from as little as 8 hours in winter to as many as 14 hours in summer. Midday rest periods, lasting 1 to 2 hours, remain a common practice, particularly during the warmest months from June through August. The evening meal typically occurs approximately 30 minutes after sunset, and sleep patterns generally align closely with natural darkness, with the average resident sleeping approximately 7.5 hours in summer and 9 hours in winter. The material culture of the region displays continuities with historical patterns, while gradually incorporating contemporary elements. Traditional building practices continue to use locally sourced materials for approximately 65% of construction, compared to 95% 2 generations ago. The thermal properties of these traditional materials contribute to energy efficiency, with traditionally constructed buildings typically using 25 to 35% less energy for heating and cooling than comparable structures built with standard contemporary materials. The embodied energy, the total energy required to produce and transport building materials, averages 3,200 megajoules per square meter for traditional construction, compared to 5,700 megajoules for contemporary methods, representing a significant sustainability advantage. The cultural landscape of Cappadocia represents a particularly harmonious example of human adaptation to natural conditions. The settlement patterns, building practices, and land use systems have evolved to work with rather than against the distinctive geological features. This adaptive approach has created a landscape where human presence complements rather than dominates the natural forms. The visual integration is particularly evident in the color palette of built structures, which typically incorporates the same earth tones found in the surrounding rock formations. Warm beiges, averaging RGB values of 226 to 8181, soft grays at 200 1190 9187, and gentle earth tones at 196 177 155. This limited color range, with standard deviations of typically less than 15 units on the RGB scale, creates a visual coherence that unifies the built and natural elements of the landscape. As we conclude our gentle journey through the ancient valleys of Cappadocia, we might reflect on how this landscape embodies a particularly serene form of time. The geological processes that formed these valleys operated at an almost imperceptibly slow pace, with each rounded form and graceful curve representing thousands of years of patient shaping by wind and water. The human history layered upon this geological foundation similarly represents a gradual accumulation of adaptations and adjustments, each generation making modest modifications to the practices of those who came before. The rhythm of seasons continues to flow through this landscape much as it has for millennia, with the same winter winds, spring rains, summer heat, and autumn harvests that shaped the lives of countless previous inhabitants. As you rest in this understanding of deep time and gentle cycles, allow your mind to settle into this same unhurried rhythm. The valleys will continue their gradual evolution through the night. The stars will trace their ancient paths across the sky, and the soft tuff will surrender a few more grains to the patient work of time. In this continuity, in this gentle persistence, we find a particularly restful perspective, one that has welcomed countless generations into its peaceful embrace, and now welcomes you into yours. As your consciousness drifts like the occasional dust, mote caught in a shaft of sunlight filtering into a Cappadocian cave dwelling. Know that these ancient valleys have witnessed the slow breathing of countless nights and days. The same soft rock that has sheltered so many dreams now holds space for yours. Rest well in the gentle embrace of geographical time, where a single human night is but a moment in the ongoing story of this tranquil landscape.